Now we're going to find the area. We're doing question 21 on section 310. We've got to find the rate of change of the area given that the length of this rectangle is 12 centimeters, the width is 5 centimeters. The length is shrinking at -2 centimeters per second, while the width is growing at 2 centimeters per second. So area equals LW, so dA dt is we're gonna have to use the product rule, and we'll hold L constant, take the derivative of W, and we get dW dt. Plus, now we'll hold W constant, take the derivative of L, and we get dL dt. Now we'll substitute our known values, and L is 12, and dW dt is 2, plus W is 5, and dL dt is -2, so that's going to be 24 minus 10, which equals 14, and that's going to be centimeters per second times centimeters squared per second times centimeters squared per second, so that's going to be 14 centimeters squared per second, and that's increasing. Now we're doing part B of this question, and that says to find the rate of change of the perimeter. Well, perimeter is equal to twice the length plus twice the width. So dP dt equals the derivative of 2L, which is just 2 dL dt. And the derivative of 2W is going to be 2 dW dt. But this equals dL dt is -2, so -2 times 2 is -4. And dW is 2 centimeters per second times 2 is +4. And that's going to be centimeters per second, and that equals 0, so it's neither increasing nor decreasing. It's constant. So for part C, we have to find the rate of change in the diagonal, length of the diagonal, or diagonals of the rectangle. So the diagonal, I'll call it D, equals the square root of L squared plus W squared. So the derivative of the diagonal, and the change in diagonals, since they're identical, will be the same for both dt, equals, and when we take the derivative of the square root function, we get this, and L squared plus W squared. Then we go inside by the chain rule, take the derivative of L squared, and that's going to be 2L dL dt, plus taking the derivative of W squared is going to be 2W dW dt. Now, when you compute this diagonal, you'll come up with 13. But before we do that, notice every one of these factors, or excuse me, terms has a factor of 2, so all the 2's will divide out. That wouldn't happen if there was one of these terms that didn't have a factor of 2. Otherwise, but since they all do, then the 2's will divide out. So when we compute the length of that diagonal given those values, we get, you try it out, you're going to get 13. Now the length is 12, and L dt is minus 2, plus the width is 5, and dw dt is 2. So let's compute that. And what we're going to get is a 13 here, negative 24 plus 10, which equals negative 14/13, and that's going to be centimeters per second. And that's decreasing. And we're done.